today. We're having a panel discussion which is loosely titled VR, a tool for science, which I'm going to turn into the question, is VR a tool for science? And we can go from there. I'd just like to start, because not everybody in the room has been here throughout the day, by asking the panelists just to introduce themselves very briefly and just say what's brought you here, essentially. Why are you here in terms of VR? Can we start with you, Frederick?
Frederick from Goldsmith Computing. So I work in graphics and computer vision, and I've been interested in biomedical problems for a long time.
So I'm Paul Bates, I'm from this institute, the Crick Institute, and my interest is to somehow use these movies, VR generated, possibly to use with deep learning protocols, to try and learn from the movies' basic principles.
Aydin Twark, University of York. I'm a theoretician, mathematician by training, but work on the interface to biology. I'm from half of an investigator team with Professor Peter Softley in Leeds, who's an experimentalist. And jointly we try to understand viruses, how viruses form, assemble, and if we can explain if there are regulatory rules in the genomes. And this brings us to visual problems that can be addressed with VR, and I had a eureka moment this morning, I should say, about how VR can actually help us to better understand our virus structures.
I'm a computational biologist, Steve Taylor from Oxford. I've got a group, and part of that group we're very interested in scientific visualization, especially with large data sets and imagery. But I'm also extremely interested in the interaction users have with data sets and making that as easy as possible.
I'm Sylvia Pan. I'm lecturing VR from Goldsmith. I've started working in VR since 2005 in the kind of immersive VR we're using now. So I'm interested in how we can use those devices for science, and especially if it can be linked to the research area I'm particularly interested in, which is social interaction. Can that be useful at all?
Okay, all right, thank you. So I wanted to just take the temperature of the room to begin with. So just to ask that question, the titular question for the panel, is VR a tool for science? Who in the audience, just show of hands please, who thinks VR is a working tool for science today? It's a handful. Okay, so that's probably about a quarter of the audience. Who thinks it has potential, significant potential, let's say? So that's probably about almost everybody else. And who doesn't think it has a future in science, or it's a novelty? Okay, good. I would be surprised if you were here, really, if you did think that, but nonetheless. Okay, so on the panel, we clearly have two VR enthusiasts, I think it's safe to say, at each end of the row. But of the three of our colleagues in the middle, which one of you is a VR enthusiast? Steve, I think you were a VR enthusiast. And do we have a VR, not exactly a skeptic, but a remain to be convinced? I think, Paul, I think you probably...
I'm possibly semi. I think since this meeting I'm more convinced. Mm-hmm. Before I came here I thought it was pretty much a teaching tool, predominantly. And that for hard science it wouldn't be able to assist hard science. But I think there are certainly avenues that I've seen today where it can assist hard science. I mean, my particular point of course is to somehow hook it up to artificial intelligence, machine learning. But it isn't just that. I mean, you can see the pharmaceutical industry, a number of demonstrations where they've taken proteins and they've been able to move them in consistent ways and doctor small molecules. Of course, someone like me would like to see that more automated in terms of machine learning, but you could see that the hard value of the science, particularly when it was hooked up to molecular dynamics, and molecular dynamics was running in the background, so there was some ground truth to what these people were trying to do on the screen. I think that's a very powerful analogy to have, because we know that running molecular dynamics just on its own doesn't get there, because it can't cover all the time phases, and that you do need these mechanical manipulations for, as Mike was saying, for some very large movements, but to use the two in concert in some way to connect with really the hard science of molecular dynamics, really, because those packages have taken 30 years plus to develop, and then using the faster techniques of VR to make those connections, I think, is a clever thing to do.
Okay, Steve, you got anything to add to that?
Yeah, I think actually I agree with Paul, and I think one of the things that is going to be very useful in VR, I think we're investigating, is the combination of machine learning with virtual reality. There's a lot of work that we're doing in collaboration with people with computer vision in hospitals and also in engineering, where they want to be able to segment out things from CT, MRI, PET scans, all that sort of thing. And there's often a lot of problems with that because organs and differences between tissues are really quite difficult to do. So I'm very interested in the fact that you could actually get a mesh, a 3D model generated from machine learning, and then the fact that whether we'll be able to manipulate that more quickly with things like VR, because it's a 3D model and you're actually going to be able to interact with it. I mean, I think a lot of things that need to be done are tested to see how effective these things are. I think we're just starting to see that in the literature. There was a mention that Fred Brooks had some stuff about it earlier on, which I will definitely go and read now. But yeah, I think we need to do more testing to see if that's true, but I hope so.
And I would like to add to that the analysis of experimental data could be facilitated because you often have spatial information that you can't grasp in the data itself unless you can manipulate the data. And I think there's a real opportunity for integration of theory, experiment, different tools on both sides, and then perhaps push this to the boundaries and make an extra step with VR. So it's almost not VR on its own, but I would like to see it implemented in a bigger framework.
So there's kind of a consistent theme there of VR in concert with other technologies from all three of you. And actually, so some of what you're saying, Paul, and what you said a little bit, Steve, there is, right, you said something slightly different, is speaking to VR as a tool for speeding up discovery processes. But is that that sort of flies a little bit in the face of some of the conversation we've had earlier about the way that VR makes things intuitive, that appeals to the softer side of softer is not the right word necessarily, but the less quantitative, less automated way of doing things. Do you see that in this? I mean, so right, I think this speaks maybe to your epiphany outside.
Yes, I think there are certain structures easy to see when you look at it, but it's surprisingly complicated in data when you have the data just as values as opposed to spatial information. And it's almost an overkill to try and tease this out of the spatial information on a piece of paper. But if you have this 3D aspect to it and you can manipulate, you can rotate it and look, certain things you can easily see and automatically grasp out. So almost it would be an overkill to try and automatize certain things that you can easily get at with VR. It's certainly not lending itself to every project and every problem, but especially in our problem, it's a very easy way of getting at a piece of information that otherwise would be very difficult to tease out.
So that then raises a question, I guess, which is that how do you know which projects are good for this and which projects aren't? I mean, because when a new tool is introduced into any sphere of activity, really, there's always a tendency for it to be used for everything, for a while. I mean, we've certainly seen that with the way that the internet's evolved. How would you, so Frederick or Sylvia, I don't know which one of you would like to take this, but
yeah, I think,
how do you differentiate?
Well, I think you have to try, you have to experiment. One thing I see with VR that intrigues me is it gives you the opportunity to bring the body into the experience. So when you're dealing with data on a screen and a mouse, there's a barrier between who you are as a human and how you react to environment. I think VR has the potential of sort of using the perception that we're familiar with, intuitively speaking, and approach the data in a different way. So when I was standing next to Rylan, and she had the sort of eureka moment earlier today.
I wish I was there.
Yes, thank you for confirming. You could. I was watching, so you could see the body and the emotion and all that. I think all those aspects. I see the VR platform gives us more opportunities to sort of engage with data in novel ways. Whether it's actually repeatable, and we have to explore. And so it's more of a sort of a moment in time where I would say let's experiment and not be necessarily too hopeful on the outcome.
Yeah, exactly. I just said, because I've been in VR for quite a long time, and I've seen, I think it was the late 90s that VR was kind of the peak, and when I started, VR was kind of, not really one of the most popular terms. And then 2013, after Oculus was sort of out, they kind of went up again, and then actually VR conference started having hundreds and even close to 1,000 customers or something they had. And so I'm actually quite protective of VR. I don't want to sort of tarnish its reputation because this is my career. If it's, reputation is ruined, and then it's bad news for me. working, right? So my suggestion for approach to VR is really, as I have presented the framework, when I teach VR, I teach there's 3D models, 3D display, and 3D interaction. And as I said, 3D interaction is the hard part. And I don't think it's so costly for the scientists, because you're working with 3D data, to just have the 3D data and have it visualized on a sort of HMD device, or maybe just on a massive screen, right? And then you see the 3D data, but try to think about other ways to interact with the data rather than a mouse and computer. Maybe use a 3D mouse instead. There are all sorts of devices out there that can help you do this. But really, when you go into sort of the programming, the 3D programming of 3D interaction, that's the area you have to be careful. That cannot be done without dedication, right? You can't just say, oh, we tried this, it didn't work, we did some experiments, the result with VR didn't really help, therefore VR is not a good thing, and I will be so devastated if I hear that, because I just think that has to be, yeah.
Perhaps there's a pivotal moment in science at the moment, because we have the revolution in imaging techniques. You have cryo-EM at resolutions that we haven't seen before. You have the Titan crisis. I've heard we have in the basement here and the four floors down, 2 of them. And these data are really there to be analyzed. And the project I've been talking about basically uses these cryo-EM data to some degree, but they are not able to answer all of our questions. I think VR can fill in some gaps here, and it is really a good time for you guys now that imaging has reached that stage where you can ask questions that weren't possible.
And we have the computational power as well to render these images, but then there comes the small concern that the HMD devices we have here are actually pretty much low resolution, and we must not forget that. You know,
there are new ones coming out there, right?
There are new ones,
with the foveated rendering.
But are they close to 4K or anything? They're still not as, say, high resolution as a big computer screen could give you.
I think the new one, I mean, there's one that's about $6,000, right?
Okay.
That's just come out, the Varjo from this place in Norway, where they actually, you have tracks your eyes, and then where you're focusing, it will just render that super high resolution surrounding area.
Yeah, but we must not forget there are still the technical challenges, right? I mean, I must mention there's the CAVE system as well, which is a system I worked in, where it's like a 3 meter by 3 meter by 3 meter room. You walk in, and you have massive screen spec projector, and that's really high resolution. So there are that kind of VR system we should be thinking about as well, if we're really thinking about high dimensional, high precision data.
I think one thing we should be thinking about is how to get people into VR. If you take the analogy, my son was trying to ride a bike for ages, he just kept falling off and hurting himself. So he borrowed a balance bike from his friend, and he just used it more and kind of got used to the whole thing, and now he can ride a bike really well. I wonder if we need some sort of intermediate step, because sometimes you don't need the stand up and sort of wander around a massive location to do VR. You just want to see your model in 3D and interact with it in a certain way. So I wonder if we need to kind of have different levels of interaction, say, using a mouse and keyboard, what people are familiar with, and then have, the HMD. And then you can say, well, okay, in the same way, when you were drawing an accurate drawing with a pencil or something, you pick the pencil up and use that. That's when you maybe grab the controller and can use it to do the sort of more manipulations in 3D. Maybe we need to kind of ease people into the whole thing.
And then you probably need to then identify the situations in which the mouse and keyboard, because as we saw from Helen Deeks' presentation, there's a stark difference in the feasibility of certain tasks depending on the input technology you're using. So, I can take your point about the middle ground, but you then have a different problem, which is identifying where that middle ground is helpful, I guess. I wanted to just come back a little bit to this idea of that Frederick raised and followed up on, of putting the person into this, because this is probably a false dichotomy, really, but nonetheless, let's go with it for the moment. That seems to me like a middle ground between theoreticians and experimenters, right? It's turning objects that are known only as data or as images into, in some way, kind of graspable experimental subjects. Some of the kind of discussion we've seen about around haptics and so on suggests that actually you're taking something which you could not get your hands on in any realistic sense, turning it into something that you can. And I'm just wondering whether that, kind of to build on your point a little bit there, whether the scientists of today or the scientists of tomorrow will be trained to do, how do you train someone to deal with the realities of that? And this also speaks a little bit to that, to the point that was raised around sorry, I've forgotten the term you used, for the correspondence between perception and
Sensory motor contingencies.
Sensory meta contingencies. There you go.
Trips off
Oh,
the
it
tongue.
tripped off my tongue. It's not asking for it. But that universe of relationships between what you see and how you interact with it. How do we prepare? I mean, maybe it's the balance bike analogy, but how do we do that? I mean, how have we done it elsewhere in VR?
So in VR, there is lots of labs doing full body embodiment. Like basically, you can see an avatar of yourself with full body capturing suit. It's not. You can kind of use the consumer devices. You can do that to some extent, but obviously you just have 3 tracking points and try to reproduce a body with inverse kinematics to do that. Even with some extent. But in order for it to really sort of work in a sort of full sensor motor contingency, you need sort of other devices, more expensive devices to do that. But it's technically it's there. Just a matter of these things are still expensive to buy because the market is still small.
But the training piece of this, I mean, is this just a generational thing? Is this a
No, in terms of training, as in programming it, or
no,
people-
as in just getting scientists used to this idea. I mean, if you've been brought up, let's say you've taken the theory track, and as I say, this is a false dichotomy. But let's say you've been a theoretician. You spent all your time at a keyboard. You've never started cutting things up with your hands. I mean, that's not something that's ever appealed to you. And now suddenly you're in this world where actually what you're doing requires you to put your hands around something. Is that just something that's going to be a generational thing, or can we make that happen? Does it happen
It
now?
tends to be a collaboration. So we're computational biologists and we interact a lot with experimentalists. But experimentalists don't really have a great feel of what we do in terms of writing code, programming languages. But what they have a real affinity for is that when we create a movie of our agent-based modeling or some kind of computation and we show them the movie, they can relate to that instantly. And they instantly get ideas on how the theory should develop, on how we should improve the agent-based modeling by adding extra factors that they found experimentally. So it's a really brilliant bridge between experimentalists and theoreticians. And without it, the one team really doesn't appreciate the other anywhere near as well as it can if a video is not present. And we see that time and time again, whether it's working at the structural people, the protein level, the cell level, at the tissue level, it's always the video that captures their imagination, not the mathematics and the coding, because they don't really understand it.
Mm-hmm. That's interesting. So that's a different modality for VR, perhaps. I mean, we've talked a little bit about it making data transparent and intuitive. This is VR as a node for collaboration. Is that reasonable?
Well, it makes them understand the data as well. I mean, with VR they can see data clouds. They can understand the data as well as how the technologies can help them in their everyday life. So it's basically bridging. It's understanding and bridging between communities where this VR approach seems to really hit home very hard, actually. I mean, if you remember when you had demonstrations just outside here a few months ago, a number of biologists came along, put on the headsets, and they were just amazed because they didn't really have a feel before how quickly different cell types moved. They studied all their lives, but when they see the T cells move much quicker than other kinds of cells, they can start to think of ideas in terms of what to do next experimentally. So it really hits them hard.
Do we have any experimentalists in the room? Is there anyone who would identify as experimentalist? Sort of at the back there. Do you have any responses to that? I mean, how do you feel about being cast as the person being bridged to? I should say this is being taped, incidentally, so your answers.
Well, I mean, I guess I can speak from the experience when we began the project and we had to sort of make the communication between video game VR developers and biologists work. It was hard work. It really implied learning each other's language. I mean, I had to learn what a shader was.
For you.
And I had to learn what in situ hybridization was. And I don't think it would have really worked if this thing didn't happen both ways. Because the problem is that not any single person can do all the jobs, but if you cannot convey your need well enough to the person that then developed the software, you just can't expect people to guess it. And you need to learn how to convey your need in a language that people can actually relate to. So I think that as Silvia was saying, it needs dedication. It needs a few months where everybody suffers by showing up at each other lab meeting and passing the first hour and a half not understanding anything. and asking very dumb questions without too much fear of judgment. But then it does pay off. I mean, I don't mind being referred to the person that this needs to be bridged to. I mean, I recognize it's true, and the computer scientist needs to be bridged to what the experiments are so that they can actually build tools that are really useful for analyzing that data. So it goes both ways.
Okay.
Yeah. And I just have to think, because I work with, as a VR researcher, I actually try to apply VR on different fields. And one of the interests of, as I worked in psychology for 2 years, and I was trying to write this paper with my collaborator, and she was like, oh, the input, so when in computing, when we talk about input, we talk about keyboards and mouse, and output is the display. But as a psychologist, he was referring an input as in things we see. So the display is the input to human participants. Keyboard is how they output experimental data. I was like, okay, but I think this is, collaboration is, these are the things that what collaboration is about. And actually, collaboration is what makes science so attractive, so beautiful. It is about not only you have your way of thinking things, it's you have to understand how other people think about it from different angles. And that's when you actually create brilliant science. And that's, for me, that's what's really precious and really exciting about working in VR.
And for me, it's not just about the start of such a collaboration, the bridging at the beginning of an interdisciplinary collaboration, but I think when you have a well-working collaboration, but actually all the terminology is clear and you're already understanding each other's languages, but then you can use this jointly as a tool to look at your structure and discover new things that you couldn't, because it actually gives you that visual impact. And the other thing I've picked up from those talks, if you have this opportunity of being in the same space from different locations, and you can manipulate the structure, so say you talk to someone and you're in the same space as you rotate and say, can you look, when I rotate it like this up there, you can point, they can see it. So that's what I see for collaborations for the future. We have collaborators all over the world, and often with visual projects it's very difficult. Skype is frustrating when you say, the thing on the top right, what do you mean? The blue thing? No, not the blue, the pink one there. No, you want to be in the same space, you want to be able to point, you want to really be clear, even when the collaboration is already working and well-oiled and absolutely understanding is there.
I absolutely agree with that, and I mean, at the beginning, our experience with making collaboration work has been that unless you have already spent a certain number of hours in the same room, Skype is useless.
Yeah.
It's useful after people already know each other. Maybe this will change when VR works really well and you can have meetings in virtual space. We're actually trying to convince our developers to actually build us a virtual meeting room. But yeah, I think that unfortunately plane tickets are still necessary.
Yeah, but one of the
Well, then
challenges.
maybe we can just use it.
Yeah, it's called Engage. One of the challenges of VR and remote meetings is facial expressions, and that's a very important sign you want to capture. But if you're actually in VR, you have half a face being blocked.
I
So exactly the
I
same.
don't think we're going to convince RPIs to wear a full performance capture rig on them.
Yeah.
Maybe
We might have to stick to buying plane tickets.
I'm going to go with the motif of everybody suffers, but it pays off in the end, which I think is probably something that you can say about pretty much any project. I just wanted to, the gentleman here has
Yeah,
been.
so I was just
Could you introduce yourself? Sorry, just.
So I'm Mike Hand from GSK, Smith Kline. I was just going to say one of the earliest and most effective virtual reality tools was chemists learning to write structures, because that is a model, it's a representation of what we believe molecules look like. It looks nothing like it. But why can chemists talk to each other? They can sit down, they can write structures, you can point to things. The current devices don't allow you to do that. You're shut off from everybody else, you have to recreate the other person. Okay, that might work because they're the far side of the world. But outside here, it's a very solitary thing at the moment, being in that space. The resolution isn't as good as we need. The haptics are horrible compared to a pen to draw a structure. Yeah? There's no force feedback, there's no, you've got to point at something in a not very clear screen. I mean, the whole experience, it's interesting. I love trying to do things in VR, but at the moment, I don't think it really delivers in terms of the visual feedback, the input you can have, the collaborative environment. We're way short of what a piece of paper and a pen can actually do at the moment.
But it affords other things, perhaps. But Frederick, do you want to come back on that?
There's a lady over here.
Yes,
yeah,
I'm aware.
Yeah, I think so. I see different potentials. One is the fact that we are here. So VR has made it possible for all of us to reconsider interfaces in the context of using computers, and probably without this emergence of a new generation of hardware, we just there'd still be research in VR. There have always been for the last 40 years or so. And the goal that you're indicating, yes, we're probably not there yet. At the same time, because of affordability, a jump in performance with respect to some aspects of the VR systems, we are questioning, okay, maybe there are some low-hanging fruits and there are some applications where it makes a big, it will make a difference now rather than wait. For example, we were talking about the haptics, and I'm pretty sure that when you grab proteins and you try to dock them, that the fact that you have force feedback, that it resists what visually at the moment we cannot give you the resistance, it should make a huge difference. Now, noise and friction, and then there's also the art of sound. So one aspect of VR that today maybe we didn't really show too well with what can be done today is how different modalities will combine and complement each other. So we do have this capacity now to explore. I think we're at a stage where there's so many possibilities. We're still sort of figuring out how to combine them. And the big role in the computer science side is, I think that we have to give them that role, is the sort of crowd of people that focus on human-machine and so-called human-machine interactions. We're good with programming, we're good with the sort of 3D effects, we're good with the certification, but how do you bring all that together and create useful interfaces for this new, well, it's not a new medium, but for this new generation of that old medium, and show that it can be very useful and perhaps in very particular cases actually groundbreaking now rather than still bring new advantages that are missing and wait. So it's exploratory at the moment. I think it won't be I don't see it as ready to be applied almost everywhere and replace the screen and traditional mouse.
Are you persuaded?
Oh, completely. I mean, I've been dabbling in this area for 25 years, and some of the problems are the same as what we had 25 years ago. Some have been solved, but the experience is still a bit difficult. It's not as intuitive as everybody would like it to be, and I completely agree with her. It fits some problems, but it does not fit others. And the trouble is, everybody's trying to force. They think their problem fits into this, and I'm not sure that everybody's does. It's far better with a high-resolution flat screen for some things.
Can I? There was a hand up here. I don't know if the discussion has moved on, but if you'd like to.
Oh yeah, it was just a comment on what you were discussing, this idea, like a meeting room and Skype not being good. There is a platform actually that's been built that is really quite good. I use it quite often to go to VR events like this. You can build an avatar, you can see people's body movements. There is actually pretty good facial expression. You take a photo of your face and it actually builds an avatar. Like, not too bad, it's not perfect, it's not photoreal, we're not there yet with like motion capture and stuff, but for something like this. But it's also somewhere that you can have like a meeting, you can drop in assets, like for example, all the 3D assets that you had there, and you could have 20 people standing in that room manipulating it all together. And you can drop in and out of different scenes, like you could be in a meeting space, playing around with that asset, walking around like an engine or something you're developing, I don't know, with Rolls-Royce or something, and telling the different engineers from different countries, oh, look at this, oh, look at that, all walking together. And then you can go out and you can watch 360 films together, and then you can go from different rooms and do different things.
What is
It
it
does
called?
exist.
Is it V-Time?
It's called real life.
Is it V-Time or Oculus Pro?
No, it's real. It's called Engage Platform. It's an education company,
Yeah.
VR education.
I'll be very curious because you said they can have facial expressions, but I mean, if you're wearing a headset, you can't actually capture people's facial expressions. So that's probably generated, which is not the real facial expression.
You sit in front of sensors when you are in.
You sit in the- which means that you will have to have what kind of sensor? Do you have to buy anything else other than what you have already paid for? What kind of VR device? Anyway,
How many
It's
listeners?
good to test it. I mean, it's obviously probably the first. It's the first of its kind that I've ever used. It was very handy. Obviously, there's ways to go, but
Okay, so that's something we can check out. How many people in this room have actually ever tried to have a meeting in VR? And this is a meeting of VR people. Come on. Yeah, mine. So I think maybe there's room for exploratory study in that area.
yes, so there are lots of studies in that area, but I can say that, the reason why I got in VR is not because I think people should move their social interactions in VR. Actually, my very first PhD project in VR is about using VR to train people to build confidence so that they can, for those who are afraid of social interactions, can actually enjoy real life. So for me, nothing replaces face-to-face interaction, and I don't think anything will. And there are augmented reality devices, for instance, we can probably all wear together when we're talking about a virtual object, which might be helpful. So we have that shared experience while sitting together, but then something else simulated that we can share and talk about. So I think in that content is useful. But again, it's not VR against social interaction, but how do we use VR to,
I agree with you. It's preferable to be in the same room, but you can't always do that because you have
Exactly.
collaborators in the States and want to have a
Exactly.
meeting.
Yeah.
So I think it could
Okay,
be a good
I-
surrogate.
I think we're drifting
exactly.
into VR in general at this point. And there are a couple of hands at the back. So Williams went up first, so I'm going to take this. This is not a seniority thing. It's just he's talking first, then we'll come to the others. William.
So my question is as follows. So imagine we're in the future and VR has developed to such an extent it's being used as a diagnostic tool. So it's a tumour's loaded into VR and the prediction is run to say, well, in 3 years it will look like X. And the challenge is you've taken on lots of programmers who may have done all sorts of tricks, like games programs always stick in Havoc physics, which is great for games physics, but not for medical physics. And then you're at a point where you've got to do medical ISO compliance on this piece of software to deploy it in a hospital context. So how do you know at that point the model is true? Because you as the clinician or the scientific expert, you're not the programmer. You don't know what exactly the software is doing.
I can answer that. Well, I can't. I'll guess that answer. I think one thing you've always got to do with any biological or experimental technique is have access to the raw data and make that really easy to use, because we have abstractions in science all the time, and you can make all sorts of generalities if you get a bit of data wrong. Maybe you're doing machine learning, you've biased your training model and it's wrong. You've always got to go back to the raw data and say, well, is this correct? Are all my assumptions correct? And it just means, unfortunately, really good to like bookkeeping and audit trails to make sure you can always follow it up.
So this is classic machine learning in a way. I mean, you need a training set, a test set, and a validation set. Validation is really important. That's the real life scenario, basically. As I was saying in my own talk, if you don't go back to reality and validate your computational tool, then people are just going to lose faith in it very, very quickly. So validation is of the essence here. But in general, VR, I mean, you are putting a lot of, I know that you're putting a lot of physics into this, a lot of mathematics into this, and very carefully build these products, right? So that when you show an experimentalist your video, they're very savvy actually, that they can tell very quickly as to whether it's behaving according to proper physical principles or not, right? So in a way, your audience is a validation as well. Would you agree with that? I mean, that they can very quickly see whether you just kind of, like you were saying, just basically doing a games kind of motion with this, but not really a proper physics.
Yes. And you get the question, and you have to be honest and reveal how it's done, of course, and you don't want to mask anything.
Right.
And then argue for let's bring the better models in. So you want to be open about it.
It's difficult,
What's
though,
in
isn't
the
it?
box?
Because, say, for example, with the chromatin modelling that we do, it's our best kind of restraint-based kind of system. But, if you look at if you went into a nucleus and looked at the most high resolution, say at the atomic level, if that existed, there'd be a lot of stuff that would be wrong in that. It's just the best guess we've got at the moment. So, as long as the scientist realises that that isn't the ultimate kind of right answer and has that background to understand that, I think that's quite important.
I do feel like so I speak as an astrophysicist by training, and there's kind of a cautionary tale there, I think, from the kind of big data projects that have gone on in physics, where there's a kind of confirmation bias. So I look at the state of physics at the moment, of particle physics, cosmology, that end of thing, not particle physics really. In looking for answers to questions they already know, they found the answers to questions they already know. And I wonder about, whether making big biological data useful in new ways sort of has a risk of falling into the same kind of trap, because I appreciate what you're saying about scientists need to be able to appreciate whether this matches what the raw data looks like, but past a certain point, past a certain scale, that surely isn't possible. There's no intuitive way of looking at the raw data and saying this seems right, isn't it?
That's less of a problem now because of these orthogonal data sets. So you're interested in chromosomes and chromosome structure, and so are we, by the way. And I know that you use the high CMAP to construct those chromosomes, but there's also orthogonal data that you can validate against, like with the SLORM technology, for example, where you're looking more at densities. So it was a problem in times gone by when the data sets were fairly limited and of one basic type, but now we have multiple types of data. So if you train and test and develop your mathematical model on one section of data, it should also agree with other sectors of data. So it's becoming less of a problem than it used to be.
Actually, that's why my analogy breaks down, because there is only one at HC. Okay, to go to the gentleman in the blue jumper at the back.
Yes, Andreas Schaefer, I'm a group leader here at the Curriculum Neuroscience and Physiology. I'm wondering, a lot of historically VR has been developed for putting us in a virtual reality that's somehow mapped on our surrounding, but as has been pointed out by many of the speakers, in exploring scientific data, one of the key aims can also be to make things accessible that we don't have an intuition for, typically something very small, blood vessels or individual cells, nuclei, or electron microscopy data, like what we work on. So my question here is, the challenges you face with these kind of data sets are that they are not sparse like our normal environment where we have a line of sight, but they're very dense. Does that create conceptually different approach to VR, or is it just a matter of making sure you get rid of the right kind of data when visualizing? It's a question to, I guess, all of you.
What do you throw away, I think is the question.
I've never actually tried to visualize biological data, but I guess, from my experience, I haven't done anything in biology for a long time, but anytime I want to grasp a concept, I guess I always try to think about things that I'm familiar with and compare this sort of abstract concept to things I'm familiar with, think about properties that imagine something that I really know well. So I think maybe that could be a rule to apply when you visualize those kind of data as well. So there's no good way to really visualize data as it is, but in order to help people to learn this data, what are real world objects we can sort of compare that to, will probably be a good guideline of doing it.
I'm not sure about Andreas's question, but I think what he's saying is that he's looking at environments that are very complicated, and he almost wants to filter things out in a kind of like a parsimonious way, things that are maybe more static and maybe look at things that are more dynamic, filter out, and then a computational biologist think about those aspects and not more stationary, or then bring them back somehow. To somehow partition the space, Andre, is that what you're thinking of?
Well, I'm very, very egocentrically thinking about our very large-scale EM data sets, so that tens of hundreds of terabytes starting off with random grayscale. So now, of course, the typical approach we take is segmenting and trying to look at that. But then how do you interact with those kind of data sets? Best, they're inherently 3D, but you can't look through them. The only way you can look through them and actually interact with them would be to, I guess, get rid of most
it's to
of
filter
them.
some things out.
Well, that's kind of what we do with Babel VR, right? We take the different properties of voxels, and we can kind of like use cutoffs to kind of filter these and get rid of certain things.
Are there any other ways to think about dealing with these data? Because typically, I guess, you look at a single cell, you look at an entire organ, a
Yeah.
tumor, it's always dense, and that's very different to our
I
normal-
think,
I was just thinking. I think the thing is, you can do it very quickly with, as long as you can do it very quickly with the tools and try things out really quickly and kind of almost flip between two different sides of it. I think that's very helpful. Whereas if you've got something where you have to run a simulation for like a day and then come back to it and you've kind of forgotten what the previous frame was like, then I think it's difficult.
But it depends on the nature of your data. Suppose you have a data set where you know that some parts are more floppy or more movable and some are more static and more sure. So you can perhaps take the part of the data that you're more sure about, that have a higher probability of being in that place, and then strip the rest away, and then it depends really on your problem. So for us, we had the cryo density of a packaged genome, and the density that's closer to capsid, which is more defined, was obviously more sure and more clear, and certain things that are further inside, a bit more floppy, a bit less clear. So what we did was to keep the contacts between the RNA and the protein that were really sure and that were modeled in by an experimental group to atomic detail. We took those 15 contacts and said, let's strip the rest away for now, let's make contacts between those, and then look at probability distribution of folding propensity, map that on, and then you can bring the rest of the data back in. So you shouldn't lose them, you should just maybe use them at a different time point, bring them back in and compare that with what you've created in the VR. So I think it's a matter of perhaps looking at the nature of the data and the nature of the problem. I'm not sure.
But possibly, one more point on this, possibly the formal way to do it is in a convolutional neural network way of doing it, where you pass a kernel function through your data, and it will sharpen up certain aspects of it and tone down others. What those kernel functions are, though, may be difficult for you to find, but you could do like a trial and error of different kernel functions and then see what kind of convolutions you get at the other side.
Okay, I think we're getting into the weeds now, but that's an interesting point. So this is kind of an unsolved bug. I suppose this is where the scientific judgment comes in at this point. Gentleman here in the blue jumper. So can you just introduce yourself? Sorry.
I'm Tisham, and I'm a software engineer at Imperial College. So you mentioned augmented reality. So is augmented reality same as virtual reality, or they're overlapping?
Yeah, so I just said, when people have asked me what is VR, I said 3D model, 3D display, 3D interaction. And for me, the difference between augmented reality and virtual reality is 3D display. Basically, the two things. One, with VR, you're immersed in a place. You don't see anything in the real world. And then these are really good for certain applications, but not so good for others. For augmented reality, you still see, you have a see-through pair of glasses, but then they superimpose virtual objects on top of this real environment, and then involves a lot more sort of machine vision, because we have to be able to have cameras that scans the actual room so that I can locate virtual objects in places that actually make sense. And that's the difference between VR and AR. But in terms of 3D model and 3D interaction, is actually very similar in how you design and think about the sort of technical.
We haven't actually talked about AR or XR at all actually while we've been today, which is perhaps as a function of the
I think we
variable.
mentioned once.
Yeah, I mean, would either of you like to just briefly? I would like to get through a couple more questions.
Well, we were talking about the limits of VR even today in terms of what's possible, hardware-wise, computational-wise. So AR is even not as mature, at least at this phase, in terms of what's available off the shelf. But there is a lot of work going on in different companies, including like in Cambridge and Microsoft. So you may expect sort of a frenzy of AR applications in a couple of years, like we've just seen with VR.
But we're not there yet.
But as Sylvia was mentioning, I think it's going to be, we're probably going to end up in a similar place where we have yet another way of doing 3D type of interactions, and we're going to have to figure out where is this useful and how to use the medium. I just wanted to bring a related point before I forget to bring it. I think there is an opportunity with this VR, perhaps AR version, to relate to, again, our perception. I mentioned that before, but we were mentioning before that there are people who are more experimentalists, others are more intellectual maybe, or sitting doing programming. I think everybody has had to learn using their body when they were a child. the other thought here is we saw William before doing drawings and exploring ideas. Everybody has used drawing to learn. So I think VR has this interest compared to traditional computer interface that it is bringing us back closer to the way we learn about the world, which is about three-dimensionality, about sonification around us. It's still missing some key features from the perception, which one being haptics. But there is something else to think about, is that differentiated from the traditional computer interface. And I hope that there's promises there, that we will reach the point where actually this is very different, because everybody can intuitively relate to what's possible there without having to be a programmer or understand what's on the table.
I was thinking idly earlier on about what would happen if smell was built into this.
And
What would
then
happen if you could smell a tumour? I mean, what on earth would that do to your perception of what you were studying, if that was something that...
So yeah, I've been to a lab where they put a tube in my nose,
Yeah.
pumping oxygen all the time. But when I get close to something, it changes the smell, and then move away. Obviously, then it start pumping oxygen again. So you can't really say, put some smell next to someone, because when they then move away from that object, you can't get rid of that
Yeah.
smell. So it has to be a tube into someone's nose.
Well, I think in
to achieve that.
biomedicine in particular, I think putting some of that element of the visceral back in would be an interesting experiment. You had you had your hand up. I don't know if the moment has passed.
So people have been saying that very much machine learning and VR are going to go hand in hand, and they're partners. I would say they're competitors. So, I mean, let's look at the breast cancer. I mean, what we're seeing is previously people used to look in 2D images, and now the trend is to use machine learning to get rid of the visual representation, because the aim is that that's going to be more accurate. So I would argue that if you use VR, it's an admission of failure, that you haven't got the algorithms to tackle this problem scientifically.
But yes, but you do have to keep iterating, and that's, like the study of active learning, for example, in machine learning. When you do your training, you have to constantly modify your training to make sure if you've got less number of, say, training sets, then you have to kind of modify it and build on that, and you want to do that more quickly.
So that's what I was saying. Yeah, as I was saying, you need to create these synthetic data sets, particularly for deep learning. There isn't enough experimental data there to train learning.
No, I mean, what are Google doing with mammograms, for example? I mean, isn't the idea is they're going to have a set of mammograms and have the positives and the negatives, chuck it into their wonderful black box, and they're going to be able to make a differentiation that's more accurate than a person
But you're still going to
visualizing
need to
it.
check
So
it. You've
know,
got to verify it. It's coming back to what I said earlier. You're always going to want to go back to original data, because if you get one patient wrong and that patient dies, then that's ruining a lot of people's lives. So you've really got to kind of be very careful about that. So I think you're always going to have very good visualization tools and methods to get back to that.
So do you see that VR is really going to be the sanity check for machine learning?
Well, it could be one tool in many different tools, I think, that could help.
I like to see it working hand in hand, working together, not opposing each other. There's some kind of synergy, well, hopefully that's what I'm exploring, a synergy between VR and machine learning.
I'm not sure this is necessarily has to be a zero-sum game, does it? I mean, so I think they could simultaneously be competitors in some domains and cooperative technologies in others. Surely, I mean, there's no reason they have to be mutually exclusionary in all the domains that they might be applied to, surely.
The question is also what's easier to use for the clinician. So my sister-in-law is a clinician, so she would probably use the VR, she would look at the data. I'm not sure she would do the computer processing.
Yeah, but if one gives a much more accurate prediction, I mean, she might not want to do it. But if the accuracy is going to be better because you use a black box, then that's what they're going to have to use.
Yeah.
I mean, to some extent, in protein modelling as well, the aim has, Paul and I have been working on this for a long time. The aim is to automate it, so we get rid of the human intervention. And whenever we've had to use human intervention, that is an admission of our failure. So Paul's got these wonderful programs to doc programs, and the idea is you have a server and number one comes up the right answer. And it's only when we fail that we have to go through a list of 100 alternatives and use our ad hoc judgment and say number 15 is the best.
But Mike, to automate, I had to do manual intervention first, if you remember. So in your day, in your lab, I used to do a lot of things manually.
Yeah, because that was a failure.
Well, no, because I was learning. I was in my head doing machine learning. So once I machine learned in my head, I then knew what to code. And I think that's where VR is very special and very useful, is that you look at movies and you learn from those movies, and then you translate how, you open the loop and you put the small molecule in, how you do those motions, and then encode them for automation. So I think, again, they go hand in hand. That you need both. You need the VR for the mechanical, and then you translate that into automation. So that's what you and I did over many, many years, if you remember. I used to drive you absolutely crazy. Paul, why are you doing this manually? Why can't you do it automatically? I couldn't do it automatic because I didn't know how to do it automatic, but I learned how to do it automatic by doing it manually.
Right, we have 1 minute left, so there's one hand back there who...
Is it me?
Yeah, it was you.
Okay. Hi, I'm Alex. I'm going to stand up because it's probably easier. So Alex and I have built a 3D data visualization platform in VR as well. And I'm interested in the psychological barrier to VR adoption, which obviously in this context we have supervised kind of VR experiences. And if we want VR to kind of like work, we need people to use it independently. So I'm kind of interested in your experience of developing VR software and VR experiences. Kind of how do you overcome this? What do you put in place? How do you get scientists to use it and use it?
Okay,
once a
thank
week?
you. Can we do this as one tip each, please? Starting with you, Sylvia.
Well, I never really programmed any other applications. The VR was kind of where I started, so I didn't have that problem myself, and I never really get other people to use it other than my students. So yeah, that would be my
So,
answer.
work in VR, that's what I'm doing.
Yeah.
Steve?
I think this is we need to wait and see a bit more about this, but it could go two ways. I think either we've got to make it look not so geeky and enclosing, and hopefully then the technology will kind of move forward. The other way is to think of it, well, should we be treating it like a sort of microscopy suite? They go off into a dark room and kind of like use it, and there should be a dedicated area for this sort of thing. So I think time will tell. Personally, I'd like to see it so you can almost like put on some glasses and you can interact with things, so people could do that on the desktop and don't change their workflow. But we can't do
less
that yet.
geeky technology.
And for me, it's seeing where it has worked very well. I'm a scientist, as you know, so I got in touch with the technology last year here at the Quick, and I saw that it solved problems that were similar to the ones I'm facing, and thought, let's try if it can help me. And actually, then I saw I could actually make a contribution. So I think through seeing successful projects and then trying it out, it will probably be adopted more and more. And it's certainly not the thing that I do as the main tool, but it's a tool that I'm using in the context of many other things where it's appropriate.
Okay, so success begets success. Paul?
So if I could miss out a step and not have to create my own movies, my own VR type movies, and just do machine learning, which is where my passion is at the moment, then I would just use your products and see what I can learn from your movies. So it would save me an extra step.
Okay, so commoditize, essentially. Frederick?
For us, it's always it's the designer point of view. So you have to think of who's going to use this, and you have to try to put yourself in their shoes. And, so, for example, when we developed an application of one of our VR demos here, and we think, okay, this is going to be put in New Scientist Live, and there's going to be gazillions of people, all ages. It's a very different perspective, and you have to think about who's gonna come, what kind of scenario are you going to allow? So you really design the entire thing. You think about the user, you think about the situation where it's going to happen, how long are they going to spend there. You reduce, for example, in the thinking of the New Scientist Lab, you reduce the possibilities because you don't want them to stay too long in there, and you want them to have a particular experience. So all these aspects of the experience is a design side that comes into play. And as you create these systems, probably there'll be hundreds of versions of what's needed, depending of the context and the type of user you deal with, even if it's for the same, let's say, molecular VR version.
Okay, and that's designed for the user, or if I can paraphrase, ask Frederick, basically. Right, okay, if you could join me in thanking our panelists and panelists. Since this is the end of the formal proceedings, thank the organisers of this stimulating workshop.